Hi, and welcome to the lesson about watermarks. Here we will see two different watermarks. First, a GC watermark with Apache Spark, and later late data watermark with Apache Flink. So let me start with Apache Spark. Here we are processing window data, and the idea is to show you when the window results get emitted. So before that, I will start Docker containers and prepare all the topics to the demo. Yes, I have my first topic, and this time I'm not using data generator because I want the input to be a little bit variable. That's why I will do pass through a Kafka console producer. Okay. If you take a look at the code, we are generating windows of 10 minutes with 15 minutes watermark. Let me add the first record then. The first record is just this one. I will start the window watermark processing. And you can see that we have our first window, and now the watermark is 845, but you will see later that it's not fully true, because for some specific states, like here for Windows states, the watermark computation is a little bit different than just a simple subtraction of max event time or min event time and allowed lateness. So let me now insert another state, another input record, this time for a different window. Yes, you can see that we have different window, and typically here our watermark shouldn't be changed, right? Remember I said if with our dummy algorithm the watermark is 845. So now if I insert the 841, I shouldn't get it included, but surprise, surprise, it gets included in the previously created window, simply because the event time here is computed not as event time minus delay, allowed delay, but as the mean time of the window related to this value. So here we have 845, which means that we can still open the 04 is 840 window. So typically this is our watermark. To show you that, I will just add another late event. This one shouldn't be included because it's behind the watermark. Is it the case? Yes, you can see that we have nothing here, and now I will add an event for another window a little bit more in the future. The counter incremented, and now I will just prove you that this event closed, I would say, the possibility to include the data for the 840 window, because you can see that the event time is 950. If we subtract the 15 minutes, we get 850. So yeah, you can see that we don't have this window anymore. So that was for the GC watermark in Apache Spark. So I will now open the project for Apache Flink, and while the watermark management in Apache Spark is quite easy to understand, because all the work is delegated to the framework, both for filtering out late records and emitting the results, there is I would say, small drawback. As a user, you cannot access your late data. So you cannot, for example, take this data and write into different storage for example, some backfilling work. No, it won't be possible. In Flink, the logic is a little bit much more, the implementation is a little bit much more flexible. You will be able to get late data and direct it to a different output. And how does it work? So we have our source, we define the watermark strategy. So here we're expecting that the watermark is only increasing just for the sake of simplicity, but of course it may not be your case. We assign the watermarks to the source, and later when we have our processing method, look what we are doing. We are getting the current watermark and comparing this value with each event time. And if the event time is behind the watermark, we send it to late data side output. That's the name of the pattern if you look at it, side output. And that way we can do different things with different operation on that. But for me, I will just print it on the screen like for the real-time data. And the single difference you will probably observe is that it will be prefixed by this and not by on-time data. And here too, I will use a console producer. So let's recreate the topic. It already exists, so I just need to delete and recreate. And I will start the producer again. Okay, I can now start the job. I will copy the first record whenever the job is started. Let's see what happens here. So it's on-time data. We don't have any watermark yet, so that's fine. Now I'm sending another visit, but for the same time. Oh, sorry. Okay, of course I will just restart it. I didn't deal with empty record. Just it was a copy-paste error on my side. So create the list and delete. Create, and I will just launch the producer. Yes, okay, I have the producer. Now I will be more careful while copying these records. So let's start the job, and I will add the first, which is should be on time. Yes, now I have the second visit with the same timestamp that should also be on time. I will send a late data. So late data because I'm expecting data to be monotonous, so to have the timestamp only increasing. And here you can see that the timestamp is lower than the previous one, and thanks to the side output pattern, we are capturing this event and writing it into a late data. Now I will just send a real-time event, on-time event that goes to on-time sync and also advances the watermark, and in the end the last event for the previous on-time watermark that, because of the watermark advanced, will be directed to the late data sync. And how does it work under the hood? Under the hood we have a side output tag that we pass to the processor method, and that we use to annotate the generated result for the process element function. And so that Flink knows that all the annotated elements need to go to a separate, I would say, a branch for the sync, and it will be like a secondary sync, while the primary is this print one that it's directly retrieved from all the non-tagged results. And that's all for this lesson. You saw that you saw these two watermark categories in action. So the GC watermark that we are using to emit and invalidate the state. So the GC watermark that we are using to invalidate the state, and of course the other one for the late input data that we can use to capture those late events and write them to a different place for example, backfilling purposes. So thanks for watching and see you in the next lesson.